All right, here's the solution to number 2 on your sample exam. It's a truth table problem. These can be a little confusing, but the truth tables are set up on your formula packet. So if you turn to that and look at that, it'll help a lot. All right, part A, write down the following statement in words. Now this means Q double arrow P means if Q is true, then P is true. So in other words, if Q, then P. So I'm just going to write that looking up above. Q is Eva is losing weight, so we just write if Eva. Let me get my pen working here. If Eva is losing weight, that's the Q statement. If Eva is losing weight, then the P statement, then Eva is on a diet, or you can just say she's on a diet. And that is all you have to do for part A. That was pretty easy. Part B, write down in words the contrapositive. Well, you have to know what a contrapositive is. A contrapositive is when you change both Q and P in this situation to the opposite. In other words, you make them contra, which means the word not. So what you would say is, and also on a contrapositive, you switch the two statements. You switch it around. So instead of starting with if Eva is losing weight, we're going to start with the other one. But we're going to make it opposite. In other words, not. In other words, here goes. If Eva is not on a diet, so we're writing the P first since it's a contrapositive, then Eva is not losing weight. So you switch both statements, you switch the order of the statement, and you switch them to not, the opposite. Contrapositive. Okay, now for part C, this is the trickiest part. Determine whether your statement in part A is logically equivalent to your statement in part B. Now, logically equivalent means the truth tables are going to be the same. So what we have to do is set up the truth tables for both of those. And I've got that started down here in the working section. Now on your truth table, this first part, this is right off your formula sheet. If the first part of the statement is true, the second part is true, then the if-then is true, and so on and so on. So what we're going to do is set up another truth table for the second situation where we changed it if Q, then P. So we're going to set this up referring back to this first table, Q, true, false, true, false. So I'm just copying the Q's right off of here. The P's go true, true, false, false. Now to see whether the if-then is true or false, what we'll do is refer back to the first table. If you have two trues, notice two trues give you a true. A false true, that's this line, gives you a true. A true false, which is this line, gives you a false. And then a false false gives you a true. So in doing part C, we're trying to see if these two truth tables are going to be the same. If they're the same, then the statements are logically equivalent. Now not P, looking over here, everything not P would be the opposite. So instead of true for P, this is going to be false. The second line for P is true. I change that to a false. The third line for P is F, false, so we make that a true. And the fourth line, true. Same thing for the not Q's. We just switch everything. So looking back to this second table again, the not Q's are going to go false, true, false, true. Now for the third, we refer back to the first table. When you have two falses, the answer is true, referring to the given table at the very beginning. If you have false, true, it's true. If you have true, false, it's false. And if you have true, true, it's true. Now notice, this is exactly the same as that. In other words, the two truth tables are the same, therefore they are logically equivalent. And that is the justification for your answer. So this problem is done. Now that part C was a little tricky. The first two parts, as long as you know what a contrapositive is, not too bad. All right, done.